Hello and welcome to Elektor Engineering Insights. I'm Brian Tristan Williams. And today we're exploring how the car industry is being transformed by software. The term software-defined vehicle gets thrown around a lot. But what does that actually mean in practice, and how close are we to seeing it in every driveway? Joining me now is Dr. Dirk Slama, Vice President, Partner Ecosystems at Bosch and Chairman of the digital.auto initiative. Dirk, thanks for joining us.
Brian, thanks for having me.
You're just the right guy to have. Dirk has spent more than 2 decades leading digital transformation projects across automotive, aviation, and other industries, and he's helping shape the path forward for SDVs through open collaboration and digital-first engineering. So I'm looking forward to this conversation. Let's talk about our giveaway, as always. We're doing a giveaway during the show, and this time it's a software-defined vehicle. It's the Crowbot Bolt Smart Robot Car Kit, powered by an ESP32 and great for Arduino or MicroPython projects. So we'll share the code word a bit later. Stay tuned for your chance to win. And now I'd like to just thank our sponsor, who this time is Mouser. Do you want access to smart browsing and searching tools that make it easy to find the parts you need quickly? Today's episode of Elektor Engineering Insights, sponsored by Mouser Electronics, will help you with your next engineering project. Mouser stocks the latest innovative products from leading manufacturers that will help you develop the best designs for a variety of applications. Head over to mouser.com to find out more. Now, on with the interview. Dirk, thank you for joining us. We've got people all around the world: Tunisia, USA, Belgium, Argentina, Philippines. Very popular topic and very interesting topic. So let's start with the basics for viewers who aren't knee-deep in embedded systems. What is a software-defined vehicle, and how is it different from how vehicles have traditionally been engineered?
Yeah, it's a very good question, Brian. So in my experience, you ask 5 people this question and you get probably 11 and a half answers. Obviously, cars have been to a certain extent software defined for the last couple of decades, right? So we have lots of software in embedded parts of the vehicle. And I think what we're seeing right now is that we're combining this with increasingly end-to-end solutions, and that we're trying to bring in also best practices in terms of environments, runtimes, but also methodologies to onboard compute. So in the future, we see more combinations of deeply embedded with higher level containerized quasi-cloud-like environments on board. And then basically we have more and more use cases that combine off-board cloud, onboard containers, onboard embedded in zonal architectures and so on. Yeah? So it's not, strictly speaking, something new, but it's basically building on what we had and introducing a lot of new dimensions here, I would argue.
Well, I'm old enough to have had a car with 0 computers in it, a carbureted Ford pickup truck in the 80s, so that makes me ancient. But you've said that there's no shortage of tech or standards for SDVs, but rather a lack of methodology at the moment. Can you explain how digital.auto is turning that insight into usable tools or workflows?
Sure, Brian. Yeah, I mean, the good news is that there's a lot of people focusing on enabling technologies right now. Yeah, so we see a lot of initiatives, for example, even in the open source world. And I think Brian will talk about this in more detail later. Yeah, but what we're seeing right now is that, especially for the incumbent OEMs who are used to work in a certain way, it can be sometimes challenging to work and operate in these new ways of working. Yeah? And even if today we have clarity about the tools and the target architectures, if we don't have a matching organization, that's a challenge. I don't know if you're aware of this law called Conway's law, which basically says that your architecture will always follow your organization. And I think this is also very true in software-defined vehicles. So we cannot ignore important aspects, even like procurement and so on, right? And this is basically where we have set out with Digital Auto, and basically started to bring together the experiences from a lot of the participants in our community to create a best practices framework. And if you don't mind, Brian, I would actually share how it looks like. If I
Sure.
can share my screen, is that working?
Yes, that's working.
Okay, so you can see the SDV guide that we've developed with a lot of insights out of the Digital Auto community. So on this guide, you will find the SDV 101 and SDV 201 training course. And you will also find this Pulse framework here. And this is basically bringing all of these best practices together in a single view. So as you know, in the automotive world, a lot of people are used to working in V model, combining this with other, well, depending on who we talk to, well-established or legacy processes. You will find things like ASPICE and so on in this world. And then on the other side, you have the agile world, which works very differently. So what we've basically seen is that in automotive, it's important to accept that we have different value streams, and these different value streams are moving at different speeds. So everything that's mechanical, where we're talking about potentially changing a supplier setup or changing a manufacturing setup and so on, is moving at much slower speeds than, for example, anything that's digital, where we typically have much higher speed of change and much higher speed of development and so on, right? Basically, what we're trying to put together here and illustrate here is that we need to bring these worlds together. We need to bring together the traditional V model centric way of working with the agile way. And we have a lot of elements in this. So it starts, of course, with the enabling side of things, where we have, for example, the cost perspective. Then we have topics like requirements management. That alone is a really interesting topic. So what we're learning is that, for example, the faster moving OEMs have managed to reduce the requirements that they are capturing and that they're trying to trace throughout the cycle by more than 50%. And that's obviously huge. If we have 100,000 and maybe a million requirements for an entire vehicle platform, and need to combine this with a lot of vehicle variants, if we can cut this down, this is huge. And of course, managing requirements for everything that's fast moving and digital is very different from managing requirements that's, for example, mechanical. And the same applies, for example, to systems engineering. So lean systems engineering is a key topic. And then, Brian, you mentioned digital first, and I understand we'll talk about this in more detail later. That's a key topic here. Then another topic I think we'll touch on later on, also loose coupling, so vehicle APIs and so on. Obviously, loose coupling is a key prerequisite to have work streams and value streams moving at different speeds. And then, of course, we have CI/CD automation, we have continuous homologation, we have measure learn, and so on, right? So all of this together is the Digital Auto methodology that we're building out here. We're calling it the Pulse framework, and obviously I'm happy to talk in more details about this. But this is for us the starting point.
Well, that's interesting. In the past, speaking of digital first, you have contrasted automotive's V model complexity with digital first approaches like shift left and shift north. Can you walk us through a real world example where those strategies significantly reduced integration problems or your time to market?
Yeah. Well, one example that we've used as kind of like a blueprint is what we're calling the passenger welcome sequence, right? So we want the vehicle to measure the proximity of the driver to the vehicle, and then when the driver is getting close to the vehicle, we want to start an algorithm that's highly personalized. So, for example, we want to actually automatically open the door for the driver. We want to adjust the seat position. We want to adjust the language settings in the vehicle. We want to maybe even enable something like, bring your own device, where you could even have like a add-on coffee maker or something like this in this algorithm. Yeah, and this is a quite complex algorithm that needs to integrate with a lot of components, right? So obviously we have the proximity sensors, we have the door servo motor to open the door. Opening door is a quite complex algorithm, so we cannot expose this directly to the passenger welcome sequence. We need to wrap this into a safety shell that first of all checks that nobody is approaching the vehicle from the back, that there's no obstacle on the side of the vehicle, and so on, right? Then we have a lot of interactions with the cloud backend, where we get, for example, permissions. Is that driver actually permitted to open that vehicle? We get a driver preference, the driver profile, which, for example, includes the driver preferences and so on, right? So for this type of algorithm, which would be one example or one flavor of SDV, we would start, like you said, Brian, with a shift left approach, where we basically develop this type of algorithm, for example, initially against a vehicle simulation. So where we simulate driver proximity, we simulate the door opening, we simulate the seat adjustment, and so on, and have this algorithm initially run completely against simulations that are encapsulated behind the APIs that we are using, right? So we have the proximity API, we have the door opening API, and so on. The whole passenger welcome sequence algorithm would still run on board, but it would actually run in a containerized environment on the central compute unit, right? And then basically use these vehicle abstraction mechanisms to interact with all of the different subsystems on board, right? And basically our experience is the further left we can shift development of these type of algorithms, the better we can detect early acceptance problems, either within the organization, so we can basically do multi-stakeholder reviews of what we're doing here, or actually with customers, so we can bring in test customers very early to test this out. We can our type of test environments to do this, and so on. And I mean, I think everybody appreciates the further downstream we detect any issues and problems, typically the more expensive it becomes to fix them. So this is why shift left is quite central. And then, of course, when I look at the complex stack here that we're building up, typically you need to break it down. So you create one shift left type of environment, for example, for the passenger welcome sequence that I was just outlining, and you would create another environment, for example, only for this door opening mechanism, right? And the door opening mechanism might actually require a much more sophisticated virtualization environment, because here we have a mechanism which is much more time sensitive. So it's really important. I was talking early on about the the decoupling as part of this, to make sure that we're not trying to put everything into the same box, so to say, but rather via decoupling. In this basic example, the passenger welcome sequence versus like opening the door, moving the seat, and so on, to have dedicated and separate virtualization and test environments. And the closer to the hardware we're getting with these different sub-functions, the more important, obviously, it becomes that the virtualization environments are, for example, supporting even like real-time based co-simulation and so on. Whereas, for example, the passenger welcome sequence, I would argue you can use a much more lightweight environment for testing this out, because for this particular algorithm, the real-time requirements and so on are much different from anything that is feeding into this, like the door opening.
Yeah, it's so incredibly complicated. So having abstraction layers and APIs is very important so that the people interacting with the system don't have to know everything that happens at the back end. I mean, one small microcontroller can have a 300-page manual for it. So it's good that we got you working on that. How close are we to having stable API contracts in vehicles that suppliers or third-party developers can reliably build on?
Yeah, it's a very good question, Brian. I mean, define stable, right? Are we talking about one vehicle from one OEM's point of view? Are we talking about, a whole series of different models for this OEM, or are we even talking about cross-industry standards, right? So we've been working very closely with the COVISA Alliance, the Connected Vehicle Systems Alliance, which in our experience is actually really spearheading this topic of vehicle standardization. And within COVISA, there's currently one standard which is focusing on what we're calling the vehicle signal abstraction layer. We think this is a very important undertaking in terms of the standardization, but we also see that a lot of the OEMs have started with solutions on their own. So we see a lot of proprietary OEM-specific vehicle catalogs at the moment. And then there's always the question, how much standardization does the industry need actually? What's the benefit of standardization, and on which level are we actually standardizing vehicle APIs? So there is not one single area for vehicle APIs, right? There's APIs on the lowest level, on the embedded level. Then there is what on the COVISA we would call the signal to service layer, where we try to create a more service-oriented abstraction of APIs. Then, of course, there's even higher level APIs up to, for example, vehicle to cloud and so on. And they typically use different ways of defining the APIs, ways of defining the runtimes for the interactions and so on. There's different domains. For example, if you look at ADAS, for example, you have ISO standards only focusing on this particular domain and so on. And I think the level of standardization depends a little bit on the cost pressure in the different area or different domain. So, for example, if within ADAS you want to have a more plug and play type of architecture between different sensors and ECUs and so on, then that, of course, will become more important. So ISO 23150 or so might play a very important role in the future there. If we're looking at, for example, vehicle experience, which is covered, for example, by the COVISA standards, then the COVISA standard will be more important. I think Also, then you need to look at the OEM versus the supplier perspective. And so what the participants in Digital Auto are telling me is that in an ideal world, we would have maybe 80% of vehicle APIs standardized wherever we're dealing with commodity functions. Yeah, and I think at the end of the day, the OEMs need to be able to differentiate. Yeah, so for them, it's important they can still basically have certain number of APIs and exposed functions in their own proprietary portfolio. Yeah, so this is basically, I think, from the OEM perspective. Whereas if you look at the supplier perspective, it's maybe exactly the other way around. Yeah, large suppliers like a Bosch and so on, they actually strive in the commodity area because this is where they can realize economies of scale. Yeah? But generally speaking, I would argue that we're still in relatively early stage when it comes to standardization. Yeah? Whereas, I mean, we have a mature market when it comes to APIs in general and individual OEMs adopting them. But when it comes to standardization, I would argue we're still in the early stages, and it's going to be interesting to see what the current high levels of cost pressure are going to do in this space.
Great answer. I will go back to monopolizing the questions, but let's have a look at our audience and see what they've got to ask. Dave Bueno says, I'm excited about this. Glad you joined us. Dave, CJ has a question about, we said vehicles, not cars. So he wants to know, does it apply to motorcycles, boats, ships, rail? If so, what is the market like?
Yes. So a very good question. I guess there's a lot of focus on vehicles because it's a big mass market, of course, with a lot of variants in it. Yeah? So we have a lot of variants. And managing this explosion of vehicle variants, of course, is something that ties directly back to vehicle APIs. But we're seeing some exciting work also, for example, in the area of trucks. Some of my Bosch colleagues are driving this with truck OEMs at the moment, also in the context of standards bodies like, for example, Covisa. Overall, I would argue this whole concept of software-defined X, so combining vehicle APIs, combining shift left, shift north, and so on, of course, also applies, for example, to airplanes. Yeah, I mean, airplanes obviously also a highly regulated environment with a lot of very stringent safety requirements and so on. Yeah? And I'm not an airplane expert, but I would argue that they must have similar requirements where you have some things which are, as you would say in automotive, of high ASIL rating, ASIL D type of functions, and then other things which need a more subtle analysis. Yeah? I mean, this is not so black and white. We're not only talking about airbag versus Angry Birds, but we have a lot of use cases that kind of like are in between, and being able to address these type of use cases in an architecturally more sound way, I would argue is something that goes way beyond vehicles.
Okay. Then two related questions here. Om wants to know if connected cars can be secure from hacking, and DConti Engineering wants to know what cybersecurity frameworks and standards, e.g. ISO SAE 21434, and the other one that you see there, are most important in SDV deployment.
Yes. Super important question. I mean, this is definitely a key topic. If we cannot ensure security in software-defined vehicles, this will have a very short career. So this is really mandatory. Within Digital Auto, we ourselves are not focusing on this topic. We think there's a lot of very experienced organizations and even companies out there. I know that, for example, my colleagues from ETAS on the Bosch side are well known for the work they're doing in the space. And we're trying to build on this. So when it comes back to these architectures, for example, we try to understand, like, if I have a complex end-to-end architecture, what are the security and also, of course, always the safety angles that we need to look at? Is this something we can completely encapsulate? I mean, to not write this welcome passenger sequence example to death here, but let's say, for example, that we would have permissions stored in the cloud. Would then this permission management element as part of this passenger welcome sequence be a part of the whole safety and security discussion? And then if so, would something like ISO 26262 or as it's mentioned here in this comment, ISO 21434 be applicable to it? Or are these standards still too much focused on the individual parts? Because I think there's some standards that have been very much focusing on embedded type of systems, and we now need to learn and understand which of these standards really help us also address end-to-end solutions and analyze, for example, end-to-end event chains and so on, and make them safe and secure.
Great. Now, I used to drive to work and I hated it. It's like 45 minutes there, 45 minutes back. That's 7.5, 8 hours a week. So I tried everything to make it comfortable and not waste that time, from audiobooks to eventually I got an Amazon Alexa for auto so that I could ask it questions while driving. And you've referred to these vehicles becoming living room on wheels. It's not just a smartphone. So how does that vision change functional safety considerations and user experience design?
I mean, this is a really important question. And again, there's no black and white answer, right? I think when you look at different markets, you can see that different customers have different demands. What I've personally seen on a lot of trade shows, for example, that in Central Europe, there are still a lot of customers who are very much looking at driving performance and driving experience. Whereas if you go to Asia, what I see is that a lot of customers, especially younger customers, are taking a much more playful view on vehicles, and they actually also use vehicles differently. So they might not use the vehicle so much for longer distances, because in some countries like China, have amazing train networks, but they'd rather use the vehicles more for short-term trips. But in addition, they might also use the vehicle between coming home from work and going up to your apartment to spend half an hour to talk in a nice and quiet environment to your friends, or maybe even play a game. So in these kind of scenarios, the vehicle is becoming more like a living room and wheels. I mean, obviously, if we look into the future, and you were talking about your long rides and what you're doing on your long rides, obviously, the less attention we have to give to driving, the more attention we will give to other convenience functions and so on. Of course, at the end of the day, safety and security is paramount. So that comes first. We cannot do anything that basically endangers this. Which is why it's making so important that in software-defined vehicles, we can really get a grip on this, and we can introduce more exciting features into software-defined vehicles without endangering it. And that basically means clear end-to-end architectures, basically encapsulation, clear API layers, and so on, as a technical prerequisite. And then combining this with also new ways of working, new methods. Yeah, so one key topic that we're seeing here is continuous homologation. Yeah, so in the old world, you basically spent, however long it took to actually build up the vehicle, and then you had one big bang release and approval and validation and homologation process, and then you got the stamp of approval, and then ideally you didn't hear back for the next 4 years until you did the next facelift, right? So today we're talking about continuous homologation. Yeah? So some of the more advanced OEMs, they're now rolling out smaller updates every couple of weeks, if not days, right? Of course, again, yeah, this comes back to the whole discussion early on we had about value streams moving at different speeds, about decoupling and so on. Yeah, because if you have to re-homologate the entire vehicle every time you do a small change, that's gonna make continuous homologation very difficult. Whereas if you have a cleanly layered architecture, this kind of like bento box, that tells you, if you change something here, that is different from a homologation point of view than changing something over there. And that's, I would argue, the answer to this. Yeah? We need to be able to be much closer to the customers. We need to be able to understand how they're using the vehicle and the different, in particular, digital features in the vehicle so that we can react to this. Yeah, and reaction means not only faster development processes, but also better and faster homologation processes. And this is how all of this plays together.
Awesome. Sad news is that we're already halfway through the show, and I feel like we've only just touched the tip of the iceberg. Got more questions from viewers, and I've got more questions for you. But before that, since it's halfway, I promise to give the code word to our audience to stand a chance to win this Crowbot Bolt. And the code word for today, let me put it up on screen for you. It's drive. So visit elektormagazine.com/Elektor Engineering Insights giveaway. And the code word here is drive. Fill out the rest of the fields, including proving that you're not a robot. And good luck with that. Now, I've got some other tabs ready for you. For our audience, visit the digital.auto website, and you can get a lot more information about what Dirk and I have been talking about today. But earlier you mentioned Covisa, among others. So you are engaging with initiatives like AutoSAR and Covisa, as mentioned, and Eclipse SDV and Sophie. So each developing architectures or tools for the software-defined vehicle landscape. From your perspective, Dirk, which of these ecosystems is gaining real traction, and how is digital.auto helping integrate or align with them?
Yeah. So, I mean, for starters, I would argue they are all important. Yeah. Obviously, some have been around much longer than others. Yeah. And in some of these organizations, we're seeing much more change. We've been working particularly close with Covisa. So all of the open source projects that we're doing on the digital auto side of things are basically based on Covisa standards. And here, of course, a key topic is the vehicle API catalog. Yeah? And then what's also important to us is that whenever we do open source, yeah, we need established platforms and processes, and where we are seeing one organization actually really getting a lot of traction, especially when it comes to automotive open source, it's Eclipse, in particular the Eclipse SDV working group. If it's of interest to your audience, I could give a very quick live demo, maybe to give people an idea of how these things tie together, and like a look and feel for software-defined vehicle based on these standards. So maybe I can just share my screen again, if that's possible.
Great.
Is it visible now? I think so.
Change your tab. Okay, there we go.
Perfect. Okay, so basically what you can see here is the Digital Auto Playground. This is actually an open source project that we're running with the Eclipse SDV working group. And we're currently working closely with Eclipse SDV on creating an Eclipse Digital Auto blueprint. And the basic idea here is the following. Whenever I'm working on a new vehicle model, let's pick this one here, for example, the blue one, I want to be able to very quickly generate new ideas for digital features, create new use cases and customer journeys, and then prototype them against a realistic vehicle architecture, see how this new idea would fit in against realistic vehicle APIs, and then quickly get user feedback. Yeah? So APIs are playing a big role in here. So this is why you can see this here. We have standardized on the Covisa API catalog. Yeah? So here on the left side, we can see the Covisa API catalog that has APIs here, for example, for the hood of the vehicle, for the wipers, or for example, here for the vehicle door, right? And then, Brian, we were talking about this earlier on, the shift left. Yeah? Then we want to be able to work against these APIs. So for example, here we have a prototype library for this particular test vehicle. And in here we have this passenger welcome sequence I was talking about earlier on. So this, of course, has a customer journey. We can match this against requirements. We have here actually a quite complex architecture. I was mentioning this earlier on. Yeah, so passenger welcome running in the SDV runtime on board here in a containerized environment needs still these Covisa signal to service APIs, for example, to open the door, adjust the seat. But it also needs, for example, here the vehicle to cloud APIs. So this is, for example, here something where we've, for this example, I can show this to you here. We're working with X-Way, which is an established player.
I'm missing a white screen at the moment, Dirk. Is that a video playing?
All right. Give this 2 seconds. I have a really slow connection here, but here you can see. Here you can see now the vehicle to cloud APIs. So earlier on, I was talking, for example, about the driving seat preferences, the driver preferences, the vehicle access permissions, and so on. Yeah. So this is basically, this is not rocket science. These, for example, here are basic REST APIs that we've documented using the X-Way server here. You can see this here, right? And then this is matching against the Covisa standards, which are more the onboard APIs and so on. And then if we're basically putting all of this together, then of course at the end of the day, we have our SDV code here. We need to understand which APIs this SDV code is using. So like here, the door actuator, the light actuator, the seat actuator, and so on. And then we want to be able to quickly try this out. So shift left basically means that we need to be able to take this algorithm and, as I said earlier on, run this against a simulated vehicle here. So here, for example, we have a system from Dassault Systems running in the background that has the complete CAD model and is able to simulate this for us. And then we can basically run this algorithm here now and execute this first against the virtual vehicle. So opening the door, adjusting the lights, adjusting the seat, and so on. And then, of course, shift left means we also need to be able to go downstream. We need to be able to take the onboard and offboard functionality, and then maybe, for example, deploy this passenger welcome sequence, then, for example, on a hill test environment, or even on an environment from our test fleet here, right? So this is basically how with digital auto and these different standards you mentioned earlier on, Eclipse. So we're running fully on Eclipse. You mentioned Covisa. We're running fully against the Covisa APIs. You mentioned AutoSAR. For example, something like Open Door would still use AutoSAR. And then Sophie, for example, plays an important role, of course, for the cloud-based testing and then seamlessly deploying onto the vehicle. So this is how we're trying to bring all of these different things together here. I hope that was helpful.
Very helpful, thanks. Get our windows straight where they were. It was great to see code. That actually made me excited to see you working with the API there and opening and closing doors. You know, I've got a segue here. I mentioned that I had a 1982 Ford pickup van, as we call them in South Africa, carbureted, zero computers. But in that same year, 1982, a TV show started called Knight Rider, and I loved it. And it was a fully computerized car that could do things like open the doors. And the segues into AI. You've mentioned AI's role in both development, especially Gen AI, which when I said I had added Amazon Alexa to my vehicle, that was before Gen AI just has steamrolled the world. And of course, using Gen AI in the vehicle itself. So what are the most promising AI applications you're seeing in SDV design, and what's realistic today versus more aspirational?
Yeah. It's a super broad space. I mean, I think anything from advancements on the personalization side to, like you said earlier on, living room on wheels, to driver experience and so on. Again, I mean, if you look at something, for example, personalization, I would argue there are multiple levels on which personalization can happen. So, I mean, maybe this is about really customizing the driving performance of the vehicle depending on the customer preferences. But maybe it's also something as mundane as controlling the language settings in the vehicle. So, I mean, this might sound like a small thing, but for example, I'm traveling a lot. So I typically have at least one different rental car, different car model from a different car rental company every week. And just a couple of weeks ago, I literally spent 10 minutes sitting in a vehicle I had to pick up at the airport, which was insisting to talk to me in Romanian. I do like the country, but don't speak the language. In order to tell the car to speak a language that I at least speak a little bit, I spent 10 minutes because going through the system settings of the vehicle, I had to do this in Romanian. That was difficult for me, right? So even if, we can address these kind of smaller convenience features, this is a big deal, right? So I think that a lot of the SDV features that we're talking about are what I would call long tail type of applications. So they're not, from an OEM's point of view, necessarily huge investment if the platform is there, but they add situational convenience. And if you look at the evolution of the smartphone as we all use it every day today, this is all basically a fantastic collection of many, many, many different things working together in close formation, so to say. And this is something I believe we need to enable also on vehicles.
Awesome. Now, you've previously mentioned German OEMs such as Mercedes working on SDV and variant management, plus partners like Hyundai, Mobis. And we have a related question from Alexander. What about APIs defined, sorry, that's the wrong question. I'll get back to you, Alexander. Clicked on the wrong person. Andreas, how can the gap between variance on model level and economy of scale on component level be bridged? Is it only via APIs?
Yeah, Andreas, this is the Gretchen question, I guess I would say in German. I mean, I would argue that the way how we have more or less managed variance today on the embedded level, yeah, where we're using established tools and processes and do a lot with parameterization. This is not going to go away overnight. Yeah. So like in this example I mentioned earlier on, the welcome sequence, yeah, if I have a door motor, and this door motor basically is a tightly constrained embedded system which is using parameterization, for example, to control whether this is a left-hand drive or a right-hand drive. This is not going to go away, but we need to combine this also with ways of addressing this beyond the component level. So, for example, for the passenger welcome sequence, we did one really interesting project with a large German OEM here, where we basically implemented this passenger welcome sequence for different vehicle variants. So variants for passenger welcome sequence comes in, for example, country-specific settings, left-hand drive, right-hand drive. Does the specific vehicle actually have a motor to open the door or not? And is this subsystem working at the moment or not? Right. And what we tried to do is to actually do this on a more dynamic level. So not use traditional parameterization to make the welcome sequence be aware of all of this. So we've implemented a more dynamic solution. That was possible because, of course, in a containerized environment, we're not as constrained. So we can use configuration files, or we can even use inter-process communication to learn about the dynamic configuration of the vehicle. But that still needs to coexist with the traditional way of it's a difficult word, of using parameterization for individual vehicle components. And we need to bring these two different worlds together. And that's not only, from a technical constraints point of view, because, I mean, the established ways, they're not only established and well working from a technical point of view, but also, for example, from a, how to go from sales configuration to end of line configuration. How does this tie in with approval and homologation processes and so on, right? So this is why this world is not going to change overnight. Yeah, and this is again why I think this bento box analogy here still applies, where, for example, the door opening and the seat adjustment and so on would live in different bento boxes from this passenger welcome sequence. And then also we would apply different ways of managing vehicle variances in these different bento boxes. And of course, the vehicle variance tree is so complex that we can never test all of the different combinations. So we need to be very smart about applying different mechanisms, maybe using AI in the future to increase test coverage and so on. But also appreciate that we need different test strategies depending on the bento box that we're working on, so to say.
Great. And that question ended with APIs, and that's where Alexander comes in now. Back to your question, Alexander. What about APIs defined by, for example, Google with their Android Auto platform? Could their software dominance also dominate our automotive APIs?
So very good question. And now I need to see how I can give you the most politically correct and yet entertaining answer to that question. Obviously, it's difficult for me to make any statements that have a market influence. But let's say, I think what, again, we can see in the digital auto community is that Android automotive is significantly growing and becoming more important. And I personally currently see two different camps in the industry, so to say. There's one camp that basically says, hey, this is working for us. And Android basically has the Android HAL, the hardware abstraction layer, built in. And maybe in the future, we might even have something like a native Android SDV runtime or something like this. Why not use this, at least for these higher end type of algorithms, like this passenger welcome sequence type of algo, even if that is not directly tied to infotainment. And then there's the other camp that is looking at, let's say, more open and neutral, container-based type of environments, like even QNX recently announced quasi containers for QNX in their environment. And I would argue these are all good solutions, and it will depend a little bit on where individual OEMs are putting their emphasis.
Okay, let's take down that question. Another one on regulation. What government regulations are required for SDVs? I'm sure this would not be an easy answer because you've got all different governments around the world, but if you could give us a summary.
Yes, I can give you a very easy answer, which is it's a jungle out there, right? I mean, if you look at the current regulations, it's hugely complex. They even though we have obviously, for example, the UN standardization efforts, they still differ widely from country to country, from domain to domain, and so on. And this is where I see actually some exciting companies. Like we've been working, for example, with Certivity. It's a great partner of Digital Auto that basically use advanced AI algorithms to bring this together and give us a more harmonized way on this level of complexity. And actually, we have a webinar next week. Forgive me, Brian, but Tuesday morning next week on Digital Auto, we have a webinar, for example, on bringing requirements and standards together with AI into the software-defined vehicle. So this is a hugely important area. And I think these different things need to play together. So if you're more interested in learning about this, then please look this up on the Digital Auto webpage that Brian shared with you earlier on. There it is.
Thank you. I've put it up for you. It doesn't conflict with any shows on our time, so I'm happy to share this with our viewers.
Thanks for doing that, Brian. So we're doing this with Microsoft and Aleph Alpha together, and we have some really good stuff to show. We'll do a live demo. I'm quite excited about this because, a lot of people are still focusing on how to develop faster, but if you cannot approve faster, then this is no good.
Awesome. Well, that looks very interesting, and it's learning, which is very important. You can't just roll something out and then not teach people how it works. And I see on Coursera, you have a digital.auto instructor profile, and there's a course there, SDV 101, Introduction to Software-Defined Vehicles. You're also involved in the creation of a book, Digital Playbook. Now, this is right up the Elektor audience's alley, Practitioner's Guide to Smart Connected Products and Solutions with AI and IoT. So you're all about the education. Do you see them potentially becoming as foundational as AutoSAR or Automotive Spice?
Right. If you ask me, the answer obviously has to be yes here. But it's a long way. And I think there's a lot of very well working organizations out there. There's a lot of important and well working standards out there. And what we're trying to do is to bring them together. So, for example, if you look at www.ai sdv.guide. Yeah, yeah, thank you. Yeah, this is basically now for us the landing page where we try to bring these different things together. So here you will find the Coursera course, you will find the .pulse framework, and so on. Yeah? And basically, we see this as our job to look at what are best practices in some industries, from V-Model, ISO 26262, ASPICE, and so on. What are best practices in the agile world, scaled agile and so on? What are maybe also some challenges with these established frameworks? I mean, I don't know about you, but in my personal LinkedIn bubble over the last couple of months, I saw a lot of posts saying like, some of these legacy methods and so on, they're just, a waste of time because they're just built on dead paperwork. So how can we get away from, dead documents into, more agile, the truth is in the code type of thinking? And we're trying to bring this together. We're getting a lot of interest there. Whether this will become the de facto industry standard, ask me again in 5 years, because I think the mills of automotive, despite of all the pressure, are still milling slower than the agile world. But it's a very important topic, I would argue.
Yeah, we can't predict what will happen over the next 5 years, so I probably will have you on in 5 years so I can ask you again.
And I'm happy to do an interim check with you in 2.5 years.
Okay, great. We've got about 3 minutes left, and I'd like to ask you 2 more questions. One is from our viewer, Om. As someone who builds machine language models on embedded systems, I'm curious, how are you addressing the ethical risks of deploying black box AI models in closed loop control systems where human override may not be immediate?
Yeah, this is another very fundamental question. A, we only have 60 seconds. B, I'm not the uber expert on this particular topic, but again, you will see within the digital auto community a much stronger focus on what we call SDV X AI, so bringing SDV and AI together. And like topics like this are super interesting. So please reach out to me and maybe we can pick this up. But I think for today, it's too complex of a question.
Yeah, it sounds like you could do a whole show on just that question.
Definitely, yes.
And then I was curious to ask, you've mentioned open source tooling. We love open source at Elektor, virtualization, and even an open test fleet to help non-OEM innovators. Can you elaborate on how those are empowering external innovators?
Yes, of course. Yeah, so at Digital Auto, everything we're doing is open source. Everything we're actually doing is based on Eclipse SDV. So we don't want to reinvent the wheel. We really want to make sure that these, let's say, technical frameworks play well with these methodology frameworks that we're developing at Digital Auto. So I was showing you very quickly, for example, earlier on the shift left type of environment. What we're seeing is that this level of openness is new in the industry. So we're getting a lot of positive responses for this. We're also trying to make this as tangible as possible. So, for example, we're working with the Eclipse SDV group at the moment, for example, in establishing a lab. So this is quite fun. Brian, you may mention your vintage Ford vehicle. We bought a vintage Audi car from the 1960s, a super cute and very, very cool roadster. And we're converting this into a lab on wheels at the moment, which helps us to basically combine all of these open source standards with our methodology and make this a kind of eat your own dog food type of environment. Again, if you're interested in working with us in the digital garage on this, do reach out to us. And maybe, Brian, even we can do something together with Elektor. I'd like that.
Yeah, we should certainly look into that. We'll take that offline, obviously. I'm mirroring Teams notifications, so I suspect you may have a meeting coming up, and we have about 5 seconds left of the hour, so I'll wrap it up here. Thank you very much for joining us, Dirk, for sharing your time and experience with us.
Thank you for having me again, and thanks to the audience. Talk soon.
Yeah, the audience has been great. To the audience, don't forget to enter the giveaway using today's code word, DRIVE. You could win a Cobalt Bolt robot kit. It's perfect for getting hands-on with embedded development. Thanks again to our sponsor, Mouser Electronics, for supporting this conversation. You can find the latest components and tools at mouser.com. And we'll be back soon with more insights from engineers pushing the boundaries of tech. Until then, take care, audience, take care, Dirk, and keep building.
Thank you.